right? So everybody can see the screen, all right? So last time we said the 3 steps to find inverse. Can anybody tell me what are the 3 steps? Cindy, how do you find inverse? What's the 3 steps?
Change the x to y or whatever.
Change the x to y, yeah. What else? And then?
I forgot.
Forgot? Well, it's in your notes. Did you write down the notes?
Yeah, but I didn't have the book before, so I wrote it down like on a piece of paper and I don't have it.
Oh, okay. Did you lose all the notes before?
No, it's just upstairs.
Okay. Okay. How about Eric? Can you tell me the 3 steps for finding inverse?
You change fx to y,
Yeah,
and then you switch x and y,
yeah,
and then you solve for
y.
f.
Yeah. Okay. So it's on the previous page. Okay. So Cindy, do you see it here? Step 1, step 2, step 3. Yeah.
Yeah.
Okay. So write f of x as y. If the question already has y, then you don't need to do that, right? If the question has f of x, you write it as y first. We're gonna practice that. In the homework, you guys all did pretty good. Okay, I think most of you got 100%. Okay, finding inverse. There should be no problem. Okay, but today we're gonna do a little bit extension to that. So question 10, I'll let you carry out finding inverse by yourself. Okay, the 3 steps here. So the function we are trying to find inverse, right? Find the inverse of problem, right? And then we're gonna graph, right? So this is second thing. First thing you find the inverse, and then you graph it. After that, you have to find, we are going to find the domain range, okay? Domain range. So 3 target. And then one more thing is number 4, we need to check is the inverse a function or not, right? So this is the new things for this question. So please write out the, try to get the inverse function by yourself now. And when you finish, then please raise up your hand, okay? Is there anyone doesn't know what to do, has no idea at all? Let me know, okay, and then I can help you start. Remember to raise your hand if you finished. Okay, let's check some answers, okay? Tiana, what's your inverse function look like?
2.
2?
Yeah.
Huh? Just 2?
Yeah.
Function. Huh?
I don't know if I did something wrong, but I got 2.
Oh, just equal to 2.
Yeah.
Okay, okay, interesting. Okay. Ray, what about you?
It's probably wrong, but y equals square root of negative x plus 4.
Okay, okay. Yeah, any other answers? Donna, how about you?
The same as erase.
Mm-hmm. Okay, Trudy?
Wait, no. Y equals root x plus 4.
Plus 4, so no negative.
Yeah.
Okay, okay. How about you, Trudy?
I got the negative, well, I mean times the negative x plus 4 square root thing. Yeah.
Okay, square root negative x 4,
Yeah.
right? Okay. Anyone else got something different? How about Eric?
I also got square root negative x plus 4.
As a negative, okay? All right, so those who got the middle one here, okay, is 98% correct. Can anybody know what's missing here?
Restriction.
No, not the restriction. We'll talk about restriction later. Okay, we'll go through the steps first. Okay, the 3 steps for finding inverse, and then we'll see what's wrong. Okay, what's missing. So step 1, we write it as y, right? The f of x will write it as y.
Wait.
Yeah. Huh?
Isn't it like root x minus 4?
You want
It's
you want to
negative.
minus like this?
Yeah.
Okay, we'll go over it, okay? And then you'll see. So step 1, we'll write it as y equals to negative x squared plus 4. Step 2, we're gonna switch x and y, right? So Tiana, how do you write it? Switching x and y.
Y equals to negative x squared plus 4.
And I want to switch x and y now.
Oh, x equals to negative y squared plus 4.
Yeah, and what will be the next step after?
Isolate y.
And how do you do that?
You minus the 4, and then you put the minus 4 to the x.
Yeah, okay, so move the 4 to the other side, I will get x minus 4 equal negative y squared. And then you multiply both sides by negative, right? So that will give you negative x plus 4 equal y squared. Now here's the key part. When you want to get rid of square, what do you need to do? Iri?
I have no idea.
Okay. Cindy?
I don't know. Don't you just like square root it? Right?
Square root it, right? Okay, so we'll square root both sides. The opposite of square is square root, right? So we'll square root, and then you get y equal to root negative x plus 4. And that is exactly what you guys got, right? But I said you guys missed something, right? So what's missing here? Let's erase here. Okay, get some space. So let me ask you, huh?
The plus minus thing
Where?
in front of the square root.
In front of the square root. That's correct. Very good. Okay. So why do we need plus minus? Anybody know? No? You just remember, oh, it's a need the plus minus. Let's say we have some number square has to be 25. What number can square and give you 25? Donna?
5.
5, right? So 5 times itself will be 25. Any other numbers? Ray?
Plus.
Ray?
Negative 5.
-5, correct. Yeah, -5 times -5 will be 25, right? So that's why we could have positive and -5. So the answer for the box, right, if you want to get the answer, will be square root of 25 and plus minus. Okay, then that will give you the box, right? So if you want to get rid of the square, you have to put plus minus. Okay, so this is our inverse. You can box that, right? This is called inverse. And also step 2 here, this is also inverse, right? The moment that you change, you swap the x and y, it's already called the inverse, but we prefer to leave it in y equal, okay? So that's why we write it as square roots, okay? So let's graph this one now. We will start with the parabola, okay? What will be a good point for to choose for parabola? Let's see if you remember how to graph parabola. Cindy, what points do we use for x?
I forgot.
Parabola, quadratic in grade 12, grade 11. Do you remember how to tell the vertex?
The
No.
PQ thing. I don't know.
There's a special form that can help us get the vertex.
The vertex form.
The vertex form, yeah, very good. And what does it look like? Let's write it on the top. Y equals, I'll help you out, A, and then what?
There's like a P and a Q. That's all I remember.
Okay, very good. Yeah, that's about 50% now. Okay, how about somebody else? Help us fill in the blank. Trudy, how about you? Do you remember the APQ form?
Kinda.
Yeah, give it a try. Right.
It was A and then
X,
yeah, X minus P
very good.
squared. Yeah, bracket
Bracket
squared.
square, and then
Plus Q.
perfect, okay? Yeah, okay, so that's the APQ, and then from there you can tell the vertex, right? So that's the original function. Let me use the green, okay, to box it. Green one is the original, right, which is right here. What's the A value for A, Eric?
Is it -1?
Yeah, A is -1. What about P?
0?
P will be 0, very good. Q?
4.
4. Does anybody has questions about how we got the -1, 0, 4? You have to ask, okay? You're spending your summer precious time here. You got to make it worth your time, right? Are we good? Okay. The Q value is after the square, right? So that's why it's 4. And there's no P value, so we put 0. So which values tells us the vertex, Ray?
P and Q.
So the vertex will be at,
PQ.
which is?
0, 4.
That's correct. Okay, very good. So 0, 4, the vertex, we are going to put it in the middle of the box, of the table. That's how we choose the starting point, right? Because we know it's a parabola, but we need to know where the middle is. And once we got that, we just graph the left side and the right side. Left side of 0 will be -1, right? -2. Right side is 1, 2. And then to get the y values, how do we do that, Donna?
To plug it in.
Into which one? The green one or the red one?
The green one.
Yeah, okay, very good. So we're graphing the original, okay? So everybody please fill it in. And when you got the table, please raise your hand. Is there anyone doesn't know how to get a y value? I can help you. Let me know. Raise your hand if you're done. Okay, Samantha, can you tell me the y value starting from the top?
Square root of 6.
Root 6. How did you get root 6? Can you tell me? Where did you plug in? Do you plug in into the green one or the red one?
Red one.
Should be the green one. We are graphing the original right now. Okay, so can you try again and tell me what you get when you plug in -2? You have to do -2 squared, right? And then times a negative, and then add 4. You got it? Samantha, are you there? Say something. What did you say? 8? Okay. Can you tell me what's -2 squared? Samantha, I can't hear you. You got to speak closer to the mic.
-4.
-2 times itself will be 4, right? Hello? Samantha? Can you hear me? Samantha? -2 squared is 4, and then you times it by negative. What would it be?
4.
Yeah. And then add a 4, what do you get? What's -4 plus 4? Hmm?
0.
Yeah, very good. Okay, so the first one will be 0. Okay. And Donna, how about the next one?
3.
It'll be 3. Next one will be 4. Okay, let's finish the rest of the table. Okay, Donna, last 2.
Oh,
What's the last 2?
5.
5? You sure?
Wait. 3.
5, 6?
Mm,
What is it?
3.
3 again, right?
Yeah.
The other one, last one.
1.
Why is it 1?
Oh, dang it.
Mm.
Sorry, I'm tired.
Oh, what?
0.
Why tired?
I slept late.
Okay, you slept really late.
Yeah.
Okay. All right, so let's plot the points, okay? This should be the easy part. -2, 0. Okay, follow the points. Let's draw the problem. -1, 3. 0, 4. 1, 3, 2, 0. So this one is opening down. Okay, so far so good. Now for the inverse, does anybody remember how can we go from original to inverse graph? Eric, do you remember?
Was it like you draw the imaginary line, the 45-degree?
Okay, so the reflection line,
Yeah.
right? Okay, yeah. And then
Yeah.
what?
You you flip the parabola, the function around that line.
Mm-hmm. Yeah. Okay. So that's a good idea, right? Flipping it over, but to be more accurate, we need to get some exact points, right? How
Yeah.
can we get exact points if we
You-
know the original?
Can you use the inverse function?
Yeah, you use the inverse function and then what?
You put points in.
Okay. You can also plug in x and get a y, right? Is there another way? Since we already got the points for the original, Tiana, is there another way to get the table for inverse?
You just like flip that table. So like the y becomes x and the x becomes y.
Very good. Okay, so the faster way, if you know the original, right? Because square root is more difficult to draw. And parabola, we already know, right? You just use the points that you got, the green ones, like -2, 0 becomes 0, -2, right? Remember, inverse is switching x and y. Okay, so the next one, let's get the next couple pairs. Okay, so Trudy, what are the rest of the pair? Trudy, are you there?
Sorry.
Yeah, where'd you go?
Sorry. The thing I think cut out for a second.
Yep. So
Uh,
rest of the table.
after that, 3 and -1,
Very good.
4 and 0,
Yep.
3 and 1,
Yep.
0 and 2.
Okay, very good. All right, so follow the red point. Please draw the graph again, okay? And we should see a reflection over the diagonal line, right? That line is called y equals x, okay? That is the reflection line. Okay, once you got the graph, please raise your hand, okay? So I know everybody's done. And make sure you connect the points. All right, so let's check if you got the same graph, okay? So 0, -2, right? And then 3, -1, 4, 0. And then this one will be opening to the left. Okay, so this one you can label it, right? So the red one here is the inverse. Okay, and then the green one is the original. So f of x, the other one is f with a little -1. Okay, Ira and Donna, you guys finished the graph? Okay, all good. All right, so just make a note here, right? If the original is opening down, right? Let's write it down. Opens down. Then the inverse will be opening left. Opens left. Okay, so from this example, if we know original opens up, which way would it open for inverse, Cindy?
Wait, what was the question again?
What was the question? Okay, the question was, if the original function opens up, which way does the inverse open?
The right.
Yeah, very good. Okay, so just remember it comes in pair, down and left, right and up. Okay, they go in inverse. Okay, so this is something very unique for inverse. Everything is connected together. All right, let's look at the last part, right? So we got the inverse function, we got a graph. Now we're going to look at domain range. So here I have a chart. The left side is for original, write the domain range. And then the right side is the inverse, also write the domain range, okay? So please write them down. Once you fill out the table, raise your hand. Remember, domain is all the x values. And then the range is the y values. So it tells us where you can find the graph. For f of x, you look at the green one, okay? For the inverse, you look at the red graph. All right, so Cindy, what's the domain range for original?
X equals all real numbers, and
And
y is less than or equal to 4.
okay, very good. And Trudy, what about the inverse?
X equals, X is smaller than or equal to 4,
Mm-hmm.
and then Y is all real numbers.
Yeah, very good. Okay, so just like the last question, right? If for the previous one, right? Domain range got swapped over, right? So it used to be domain, it become range. When it's inverse, right? Used to be range, become domain. So same thing with this one. So the previous question, we started with the square root, right? And then we ended up with a part of a parabola. This one, we started with a parabola and ended up with a square root graph, right? So here we have a fourth part of the question, right? It asks, is the inverse of function, is the red one a function or not? Do you remember how we tell if it's a function? How do we check if a picture is a function or not? Does anybody remember? Eric?
Is it one y value for every x value?
Yeah, okay. How do we check with the graph then?
If there's 2 points on the same x, then it's not a function.
2 points on the same x, yeah, okay. So we call that the vertical line test, okay? So let's write it on the side if you forgot, okay? We can write it, I don't have space there, okay? I will write it down here. So vertical line test for function. So if you draw a vertical line, okay, so every vertical line has only one, okay, this is the key, only one intersection. Okay, so this is the vertical line test. If you get this, right, every time when you draw a vertical line, it only crosses the graph once, then you call that a function. Must have only one intersection only. So the one we are checking is the red one, right? So if the red one looks like this, right? Opens to the left. Okay, let's try again, right? So the graph we're graphing, the checking is this one. This is the inverse one. If we draw a vertical line, then it crosses 2 times. So you know it's not a function, okay? Now for the green one, it doesn't matter where you draw it, you only have one intersection. Okay, so the one that's opening down, right? If I try to draw a vertical line, it only cross once, right? I draw it here, it only cross once. It doesn't matter where you draw the vertical line, it only cross once. So this one is not function. Okay, this one is, yes, a function. Okay, so this should be a review, okay, when you start learning function in grade 10. So over here is the inverse of function. Tiana. Tiana, can you hear me?
Yeah.
Okay, so is the inverse of function here?
No.
Okay, let's write that down. Very good. Okay, inverse is not a function. Okay, and if you want to tell if it's if you want to tell without the graph, then you can look at the function. Because of the square root, it carries plus minus. So every time when you input an x value, it will give you 2 y values. One is positive answer, one is the negative answer, right? Or you can look at the table. If x equal to 0, right, we get either -2 or a +2, right? So 1x has 2 answers, right? Then it's not a function, okay? It has to be 1 to 1. Any questions so far? Okay, so that completes just part A, okay? We answer 4 things here. Just recap really quickly, okay? First, we get the inverse function, right? And then we graph by swapping the points. And then we get the table. And then we check if it's a function, okay? Make sure you master how to do these 4 things. And then once we know that it's not a function, there's a part B, okay? Iraid, could you read out part B for us?
Okay. Write the restriction on the domain of the original function so that its inverse is also a function. Then sketch the restricted inverse function and the corresponding function.
Okay, this is very confusing. That's why I want you to read it out. So what does it mean? What is it asking us to do here? Donna, do you understand what question B is asking?
Yeah,
Okay, so what should we do?
you try to write the restriction for x.
Okay,
ER.
and what would you want to say at the restrictions then?
I don't know. I have no idea.
No idea. Cindy, what about you? Do you understand what question B is asking?
No.
Okay, this is a very long sentence, right? Let's break it down, okay? It asks us to write a restriction. Restriction is like you can say x cannot equal to something or x has to be less than something, right? Because this restriction is on the domain, right? Domain means x, right? I want to restrict the domain for the original function. What's the domain for the original right now? Cindy? Cindy?
Hi.
Hi, how are you? Yeah, did you hear my question?
What's the domain right now?
Yeah, domain for the original.
The x equals all real numbers.
Yeah, this answer you told me, right?
Mm.
Yeah, so x equal all real number means there's no restriction right now. But we want to put a restriction on it, right? Make it smaller. Instead of all real number, I want to cut it, okay? So I want to restrict the original so that to make the inverse become a function. So let's look at the inverse. Inverse is opening to the left. Trudy, how do I make the red one? Okay, Kylie is here. Okay, let me get her in.
Sorry, I couldn't hear you because my parents were talking.
Oh, okay. Okay. Yeah, so hi Kylie, can you hear us?
Yeah.
Yeah, okay, welcome. Right. So we are on, you have the book, right, Kylie?
Yeah.
Okay, so we are on page 9. Okay, so
Okay.
for the previous pages, you can check the video. Okay.
All right. Thank you.
Yep, you're welcome. So Trudy, my question is, you with me, Trudy?
Mhm.
Yeah. So my question is for the red one, how can I make it into a function? How do I cut it so it becomes a function?
You cut the bottom half off.
Okay. So for example, like this way.
Yeah.
Yeah, okay. So you can either cut off the bottom part or you want to cut off the top part. So if I want to cut off the bottom part, okay, so Trudy, which part will be cut off for the original?
What do you mean?
If the bottom part is gone, that means original, which part is also gone?
The top part?
Original, the green one. Because
Oh,
the red is came from the green, right? Okay, so if the bottom part is gone, that means the green part, which part is gone?
The right part?
The right side is gone. Okay, let's draw it out, see if it works, okay? Let's take a look, okay? So if I cut off the bottom part, okay, look at over here. that means you have this one, right? And then if I cut off the right side for the original, for the green, it will look like that. Okay, do you think they are a reflection of each other? Trudy?
No.
Okay, reflection means that it will reflect over the diagonal line, right? Do you think the reflection line is right in the middle between the two?
No.
All right, doesn't match. Let's look at the previous. Maybe you can get a better idea here, right? The previous question here, you have the upper half corresponds to the right half, right? The blue one is the upper, right? The red one is the right side, right? So the upper and the right side will be a pair, okay? If we want to cut off the bottom part, that means we need to cut off which part of the green?
The left side.
Yeah, we need to cut off the left side, okay? So you can choose, okay? For this kind of question, you can choose. So let's erase that. So if I want to cut off the bottom part, that means I will need to cut off the left side, then the green one will look like that. Okay, so you see if I turn, let's see, I cannot do the turning. Or you can turn your head, right? At an angle, then you'll see that is this line here, the dotted line is like a mirror, right? And then the upper left looks like the mirror image of the lower right. Does that make sense?
Yeah.
Okay, all right. So what would you say the restriction then, Eric? Restriction on the original, on the green. What would you say? X has to be what?
Greater than or equal to 0.
Yeah, okay, because you are keeping the right side, okay? If you are keeping the right-hand side, then the upper side of the inverse will be like stay there, okay? Then it becomes a function. So that's what this whole question is about, okay? Because if we don't put restrictions, you have upper half and lower half, then it's not a function. It doesn't pass the vertical line test. Okay, is there any questions so far? Okay, you gotta let me know, okay? I can go back and then try to clear up.
I'm confused.
Okay, starting from where you got confused?
The drawing the graph for like
Drawing the half part or
the half part.
Okay, so do you understand what question B is asking, right?
Yeah.
Okay, the question wants us to keep only half of it. So you have a choice, you can choose. Because I asked Trudy and then she said she wants to erase the lower half. Okay, that's your choice. So of course you can do the opposite. You can choose the upper half to be erased. So if she chose to erase the lower half, that's how I get the red over here. Do you understand so far?
Yeah.
Okay, then you need to think about if I want to keep the upper half, that means the original can only have one half of it as well. Make sense? So you want to think about then which half must we keep, right?
Yeah.
So the upper half, the original corresponds to which half?
The right half.
Yeah, the right half, okay? The upper, I think about the sign. If you go up, it will be positive. You go to the right, it will also be positive. So positive side correspond to the positive side. Make sense?
Yeah.
Okay, so that's how we choose the side. So because we're keeping the right side, so here I draw the right side of the open down. And then you can double check it does reflect over the y equal x line. Make sense?
Mm-hmm.
Okay, and then the restriction we want to do is for the green one. So we look at the graph for the green, because it's on the right side, and we say x is greater or equal to 0. Got it?
Okay.
Okay.
Mhm.
So we keeping the right side, then the inverse will become a function. Okay. So if I just draw it on the, if you choose the other one, okay, let's say if you choose the lower half, it will look like that. Okay. And then, okay, let's draw at the top. Okay. So let's say if you want to choose the upper, choose to keep the lower half. Okay, so Donna, how do you draw the inverse then? Can you draw it on this? Yeah, use your mouse to draw it on the screen. Yeah, very good. Okay, so what would you say the domain then?
What domain?
Domain for the green graph that you just drew.
I don't know.
Now look at the green graph that you just drew here, right? You drew a green here, right?
Mm-hmm.
And domain, we're talking about the x. X must be what for the green? You know?
No.
The x value, what's the x value at this point? This point, the point, huh?
0.
0, right? And then it starts from 0 and then goes to the, which side?
Left.
Goes to the left. So is it bigger or smaller than 0?
Smaller.
So you will say x is smaller or
0.
equal, yes, to 0. Got it?
Yeah.
Okay, so that will be called the domain. And this domain is on the original. Okay, so you have 2 ways to write the restriction, up to you, you choose. Okay, so that's why I need to see the graph. So if you decided to use x greater or equal to 0, then you keep the upper half. Upper
Okay.
side. Got it?
Got it.
Okay, so we have 2 answers for this. Okay, anyone else has questions? I welcome the questions. Okay, it help other people too. Okay, your question can help others too. Okay, if you are ready to move on, I think let's finish 11. Okay, and then we'll have a break. 11 will be similar. Okay, just different function. It's also a parabola. Okay, and we also review parabola here, right? The APQ form. Right, so use that, try to get the table, the vertex, and then inverse, okay? So we'll do one step at a time. Let's get the inverse function first, okay? So for question 11, we'll go through this whole thing. So second time could be faster. So once you found the inverse function, please raise your hand. Okay, Kylie, how are you doing there?
I'm doing okay.
Okay, how much do you understand for question 10? Is there any part you want me to fill you in?
Um, I'll try to figure it out
Mhm.
when I look at the recordings, I guess.
That's what I try to understand right now, right? Because I'm right here. You can ask me, so that way you get into the get into learning as right away instead of later, right? So
Okay.
now you can go through the things that's happening in question 10, and then ask me. Okay, if
Okay.
any step you don't know why I do that, and let me know. Okay,
Sounds good.
yeah, you can interrupt me anytime. Okay. And don't forget to put plus minus this time, okay? If you start with parabola, you'll end up with a plus minus always. Raise your hand if you got the inverse, okay? We'll check the inverse first. Okay, Samantha, what's your inverse? Can you tell me?
Y equals plus minus square root of x minus 9.
X minus 9, is that what you said? Samantha, is it x minus 9?
Yes.
Okay. Anyone else got something different? Everyone's the same? Everyone got the same?
No.
Iray, what do you have?
I mean, it's probably wrong, but plus minus square root of x minus 3
Inside or outside?
outside.
Outside. Okay, let me erase. Minus 3, you said. Yeah?
Yeah. Yeah.
Okay. Anyone else? Cindy, what about you?
Oh, I got the same as you, Ray.
Okay, let's check, okay? We'll check the steps. So step 1, you write f of x as y. So we'll have y equal x plus 3 squared. And for inverse, you must switch x and y. Okay, so Kylie, I'm gonna help you to catch up, all right? So I'll guide you through. Okay, so Kylie, turn on your mic.
Yeah.
Okay, so we are going to swap x and y. So what will it look like?
X equals bracket y plus 3 squared.
Yeah, very good. Okay, so the moment that you swap the x and y, this is already called inverse. Have you learned this before, inverse?
No.
Okay, so the next step, because usually we like the function to be y equals something. So the next step, we're going to isolate y. So what's the first step if I want to isolate y here?
Move y to the other side.
But then right now the y is stuck in the bracket. So what should we do?
Get rid of the bracket.
And how do we do that?
Put the squared into the use distributive property and put the squared into the y and the 3.
What would it become?
Y squared plus 9.
Okay, so this is the part you cannot do. Think about y, okay? If I have 2 plus 3 squared, okay? Will that equal to 2 squared plus 3 squared?
No.
What's the left side equal?
25.
Yeah, very good. How about the right side?
13.
It'll be 13, right? So that's why you cannot distribute the square if the inside is add and subtract, okay? Yeah?
Yeah.
Okay, so instead of bringing in the square, we want to get rid of the square first. How do we do that?
You can square root.
Yeah, very good. So what will be on the right side? We square root both sides, right?
Yeah. So it's y plus 3
Yeah, y plus 3. And then left side?
is square root x.
Yeah. And then remember, if you square root, you need to put plus minus. Okay? We explained it up here in the last question. Something square, you will have positive 5 will work, right? 5 square will be 25. Negative 5 will also, square will also be 25. So the answer is always plus minus. Okay?
Okay.
Okay, so we go back here. And then now what?
Isolate y.
And how do we do that?
You can bring the 3 to the other side.
So what will be on the other side now?
Square root of x minus 3.
Yeah, perfect. Yeah, equals to y. So you must have plus minus y. So therefore, you get this answer. Okay? Yeah. All right, so this one is called the inverse, right? And then this one also called the inverse, but we prefer the one in the red box, okay? Good try, Samantha, okay? So make sure you explain. I think you got the 9 because you also share in the square, okay? So you see, sometimes we all make similar mistake. So if you ask a question, it's actually helping other people too, okay? All right, so we got the inverse now. Now it's your turn to show how to draw the graph. Okay, we'll start with graphing the original. Okay, we're gonna use the same color. Okay, keep it consistent. We'll use green for the original, the red one for the inverse. Okay, this is a problem. The green one. All right, we're graphing this one now. So think about where the vertex is. Okay, and try to make a table. Okay, once you got the graph for the original, please raise your hand. Is there anyone having trouble getting the vertex? Let me know. First, you have to get a PQ, okay? Okay, let's check the vertex first. Okay, just make sure everyone is on the same page. Kylie, did you learn about parabola APQ?
Yeah.
Okay, can you tell us your vertex for the green one?
For the green one. I didn't get that far yet.
Okay, can you tell me what's the A, value for A? Do you know what the APQ form look like?
I kind of forgot. I know I did parabolas, but I kind of forgot.
It's okay, I just want to know how much you remember, okay, so I can fill you in, right? So can you copy that up here, up there? You see APQ? Here?
Yeah.
Yeah,
Mhm.
okay, you can copy that down first. Yeah?
Yeah.
Okay, now you compare that form with this one, the question we're working on. Can you tell me what's the value for A?
A would be 1.
Very good. Okay, so A is 1. What about P?
P is +3.
In the form, it should be minus P, right?
Right.
So minus what value will become +3?
-3.
So P should be -3. Okay, P is -3, A is 1. What about Q?
Q is X.
Q is the value, is a number outside the after square, right?
My bad. Q would be 0.
Yeah, because there's no number after square, so that would be 0. So do you remember how to tell the vertex from APQ?
No.
Okay, it will be the PQ, that's the vertex.
Okay.
Okay, so we will put the vertex in the middle of the table. So that will give us -3, 0 in the middle. Got it?
Mm-hmm.
Okay, all right. And then we just graph around it. Okay, we graph on the left side of -3, so -4, -5. On the right side will be -2, -1. Okay, how about the rest of you? I only see 2 people raise the hand. Okay. Once you finish the green graph, please raise your hand. Okay, Tiana, can you tell us your table?
-5, 4.
Mhm.
-4, 1.
Yep.
-2, 1.
Yep.
-1, 4.
Okay, very good. All right, so let's go through the points quickly. -5, 4, 1, 2, 3, 4. -4, 1. Okay, so this is a very simple parabola. Opens. Okay, now here is a question. Original graph is opening up. Which way does the inverse open? Ray.
Right.
Very good. Okay, pop quiz, right? So that way you can check your graph after you get the table. Okay, so you guys can get the table for inverse now and then graph it out. See if it opens to the right. Once you also got the red graph, please raise your hand. Okay. Does anyone have questions? how to get a table? Kylie, do you know how to get a table for the red?
I think so.
Okay, can you tell me just to make sure?
Do I just plug in the inverse numbers? So the the x from the first table goes in the y in the second table.
Very good. Okay, so finish the graph, and after you got it, raise the hand. Okay, so let's fill in the table. I'll do this part now. Okay, so 4, 1, 0, 1, 4, -5, -4, -3, -2, -1. Donna, are you done with the graph?
Yeah.
Yeah, okay, you didn't raise your hand. I didn't know.
Oh, sorry.
Okay. Kelly, how about you? You finished the graph?
Yeah.
Okay, do you know how to raise the hand?
It's in participants, right?
Yes. Try it. Okay, perfect. Okay, yeah. So it will be open to the right. Okay, so I'll draw this quickly. Okay. Will be 4, -1. Okay. Here. Okay, I hope everybody got the same. Okay, now last part is the domain range. So same thing, once you finish domain range, please raise the hand. So this one's inverse. So in fact, if you get the domain range for the original, then basically you just swap to get the domain range for the inverse, right? So it's, you just need to do half the work. Don't forget to raise your hand if you finished. Trudy, how are you doing? Okay, so Trudy, can you tell us your domain range for the original? Trudy?
Oh, sorry. The x is all real numbers,
And range?
and the range is y is bigger than or equal to 0.
Yep, very good. Okay, and then for inverse, we just swap it, right? So it will be x greater or equal to 0, y is real number. Okay, so if you know the original, you just swap x and y. Okay, last part. Same question, right? We want to make a restrictions on the original. Okay, so you have the choice, right? You can choose either to keep the right side or keep the left side, up to you. Okay, so I will be doing both. Okay, so because some of you may be doing one side, right, then the other one. So same thing, I'm gonna draw two graphs and then write their restrictions. Okay, so once you finish, you just choose one part. Okay, and raise your hand once you got your graph and restrictions done. Okay, restriction. Let's put it underneath. So we're keeping half of it, okay? But then your restrictions should be on the green function.
Wait, how do you do this part?
So you look at the top, okay? First of all, do you know how to check if a graph is a function or not?
Yes,
How do we check?
the vertical line.
Yeah, very good. Okay, so the red one, right? I'm talking about the last question. The red one, because it has the upper half and lower half, is it a function?
No.
Okay, so therefore we have to cut off a part of it. Okay, so you can choose. So let's say, suppose you want to keep only the upper half. So you get the half of the parabola open on the right, open to the left. Okay, do you see the picture here? The upper half. Okay, that means the inverse, the original, you are keeping the right side. The green one is the original. Okay, because inverse and original, they always mirror along the diagonal line. Got it so far?
Mm-hmm.
Okay, so if you want to keep the upper half, then original, you can only keep the right half. Make sense?
I think so.
Okay, let's say if you want to keep the lower half, which side do you keep on the original? Upper half is the right side. So lower half, you keep the
Left side.
left side. So take a look, right? This is the other graph. Lower half, you keep the left side of the green. Got it?
Mm-hmm.
Okay. So you see, this is also the mirror line, right? For the red and green. So you can choose. So the restriction we are trying to write is for the green one. We want to answer like which half of the original do we keep? So you could say, okay, I want to keep the right side, then I'll say x must be greater or equal to 0. Because for the green, it starts from 0 and then moving to the right side. Make sense?
Mm-hmm.
Okay, then that way after you inverse, it's a function because you only have half of it. And then, or your answer could be keeping the left side. So you would say x less than equal to 0. Then you keep the lower half.
Okay.
Okay, so you just write down which half you want to keep and write a restriction for it.
Okay, thank you.
You're welcome. Well, we only have 3 people raise your hand. Only 3 of you got it? Okay, don't forget to raise your hand, yeah. All right, so let's get an answer, okay? So let's say, Cindy, what's your restriction?
I did x had like restrict x greater than or equal to -3. Wait, no,
Okay.
greater than -3.
Greater or equal to -3?
Yeah.
So you are keeping the left side or right side?
Right.
Right side, okay, so I'll draw it here. Right side will be this, correct?
Yeah.
Okay, and can you help us draw on the screen? Where is the inverse then for that half?
How do I do that again?
You go to annotation.
Oh, okay.
Yeah, do you see it?
Yeah.
Yeah, and then you annotate. Hold on, let me move it. Okay.
Oh.
Oh, try again. Sorry, I moved it.
Wait, how do I wait?
Use the mouse.
Okay. But it's not trying.
You have to press down on it, I think.
Wait.
Use annotate.
That.
Yeah, very good. We all see it now. Good. Yeah, good. Okay, so I'm gonna put it in. Okay. So we'll be here. We'll be keeping the upper half, right? So you see it's symmetry. Okay. How about Eric? What's your restriction?
I have the same one.
You have the same one. Donna, how about you?
Same.
Tiana?
I have x is less than or equal to -3.
Okay, right. So let's say this one will be keeping the left side. Can you also help us draw the inverse one on the screen?
I'm using my phone. I'm not sure how to draw it
Oh, on the phone. Okay.
on.
How about Ray? Can you help us draw the other half if we are keeping the left?
Okay.
Yeah, very good. Okay, thank you. All right. So let's clear this first. So it'll be down here. Okay, so if we have a diagonal line, right, the reflection line will be like that. So left and right side look the same, right, like a mirror. Kylie, do you understand?
Yeah.
Okay, all right, so in the homework, you just need to do one side, okay? The homework will have the same kind of question, so you just choose, okay? And then draw the graph for the one you keep, okay? So that's it for now. We'll have a break. So for 15 minutes. So I'll see you at 6:40. Okay, 6:40. Yeah. Okay, I'll see you at 6:40. And if anyone has questions, okay, you can stay after. Okay.